The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's Tech Talk on significant benefits of the thermal imaging to the commissioning professionals. My name is Sherry Adams, and I'll be the moderator for today's session. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. When you first joined, you will see an attendee control panel appeared on the right side of your desktop. On the left side of this control panel is a small tab with an arrow icon at the top. Pressing this icon allows you to minimize and maximize the control panel. When maximized, you can use that control panel to submit questions. We will be gathering any questions throughout the Tech Talk, and we will leave a little time at the end for Q&A. If you have any questions related to a particular slide, please include that number of the slide in your question. A PDF of the slides of this presentation will be sent out electronically to all those who have registered for today's Tech Talk. We will also be recording it, and it will be available on our website under the resource section. There is a new password for the Tech Talks, and that will be emailed out to all members who have renewed. So today's presenter is Ben Hickson. Mr. Hickson formed the applied technical resource consulting company Hickson Consultants Incorporated to provide expert roofing, architectural sheet metal, glazing, wall system, and waterproofing consulting services to the total building envelope and to assist customers with risk management of their projects. Since 1975, Mr. Hickson's experience in roof, wall, and waterproofing condition analysis, life cycle cost analysis, the selection of components and system designated to remedy the causes for observed problems, budgeting, design, specifications, and CAD detailing, superior repair techniques, and critical path project management have benefited numerous clients. He's received a BA in chemistry from Vanderbilt University. He's an active member of RCI. He has earned all 4 of the Construction Specification Institute professional designations, recognizing many years of construction experience and successful passage of technical proficiency exams. He's also a technical director for Roof Scan IR, the Roofing and Building Science training module for U.S. and international students under United Infrared. Mr. Hickson has an unprecedented reputation both regionally and nationally for his expertise in solving design and construction challenges involving original design, construction, and remediation issues. He is also a member of the Southeast chapter of the BCA. So Ben, I'm going to pass this to you.
Thank you, Sherry. And I really want to thank those attending, those that are excited about commissioning, those that are excited about thermal imaging. And today's tech topic will be just that. It'll be focused on the tech aspects of thermal imaging and the significant benefits of thermal imaging to the commissioning professionals. We're going to address the thermal imaging for roofing, cladding, and fenestration moisture intrusion, including air infiltration and exfiltration, and the consequences of reduced thermal resistance and thermal bridging that the infrared camera can detect. Today, our attendees will gain an appreciation of the non-destructive, non-invasive, and real-time detection capabilities infrared imaging affords at very economical costs. Those are very important in today's cost-sensitive environment that we find ourselves, also the need for immediate information. In closing, we're going to share 3 infrared training options for the attendees to gain insights into the vast building commissioning benefits with thermal imaging. Number 1, we're going to talk about roof leaks, insidious. Our logo, Think Like Water, has never been more applicable. And what you've got on the left hand there is the scale to the right, indicating the lighter colors or the warmer colors, the darker colors or the cooler colors. And even on today's really bright white, snow blinding white PVC and TPO thermoplastic roofs, thermal imaging can prove beneficial to the commissioning provider, both new construction and retrofit construction, but also in the course of major leak events, making sure that they're corrected during the course of a new construction or retrofit commissioning process. And you can see the much warmer thermal patterns easily on the left. On the right, they're a little bit harder to distinguish. You can see in the top left-hand corner the much warmer area. for the heat, the electromagnetic heat waves that are generated and detected by the infrared camera. The white single-ply roofing requires the thermographer to move around a lot and change vantage points, oftentimes change palettes, go from these brilliant colors to a gray palette to distinguish and differentiate. But you can see with the proper settings, close span, that you're going to pick up the solar heat gain in the fastener plates, in the insulation. Today's single-ply market doesn't involve the porous insulations of the hot asphalt and hot coal tar pitch and hot modified bitumen built-up roofs of the past. So what you're going to see is amorphous water under the membrane sheet. You're going to see the board outlines if water's trapped there. You're probably going to be limited to the top 2, maybe 3 inches of the system. It cannot reach down into these really deep installations that we have with the tapered insulation systems. But as you can see from both of these scans, very simple and very dynamic, high resolution thermal images telling us a lot. Sometimes in our white single plies, you will see the board outlines, you'll see the fasteners. What's that tell us from a commissioning standpoint? That tells us that in the commissioning process, not only can you detect the probable and possible concealed moisture, you can detect proper or improper board placement and fastener placement that is valuable information to the quality assurance team. The trapped moisture may be in a straight board outline, or it may be within the board itself. So you have to be very careful and again, move around, change your vantage point. There's still a number of Hypalon single-ply roofs out there. You shouldn't be seeing those in new commissioning, but in retrofit commissioning, whether or not to save the roof, whether or not to do a recover roof, you'll run into those, and they're somewhat easier to thermal image than the new-in-the-box white TPO and PVC single-ply roofs because they're aged, no longer as reflective. And commissioning existing buildings with thermal imaging can identify concealed moisture, missing thermal resistance, and improper fastener and plate face placements, much like in the other roofs. We're seeing a large number of granule modbit roof installations, both in the new arena and in the retrofit community. You can see on the left and on the right how brilliant the solar heat gain, how it's detected, and I say the thermal patterns indicating possible and probable solar heat gain of moisture. The one on the left there, amorphous, we've got a porous insulation and a leak in a valley line. On the right, we've got a flashing leak. The commissioning infrared provider is going to be looking for low points, previous leak areas, penetrations, and perimeters for finding possible moisture intrusion. You can see again the dramatic thermal imaging in this palette with the much warmer temperatures, the lighter colors, cooler temperatures, the darker colors. Some of these are very dramatic, aren't they? It's sort of like shooting fish in a barrel. People ask me all the time about scanning white EPDM membrane roofing and the black EPDM roofing. They ask white because it's reflective. They ask black because of the solar heat gain in the black material itself. And it's very important to, on the white EPDM, just like the white TPO and the white PVC, to allow time for the initial surface solar heat gain to dissipate, which doesn't take too long, especially if you've had cloud cover during the day with minimal solar heat gain. And if you've got cloud cover during the period of scanning after dusk, it's complicated because the cloud cover during the scan can slow down the heat dissipation to where you have to be patient and wait in order to get good thermal images. But you can see the ability to detect possible and probable concealed moisture with EPDM roofing is very informative, very definitive. Even the one on the right with the slight thermal pattern detected. Let's move to our building envelope, because I want to stress that while there are a lot of problems with roofing, there are more shenanigans, more problems with the cladding, with our vertical surfaces, the walls, windows, joint sealants, expansion joints, control joints, and the connection between cladding and pavement, cladding and grade. In these images, you can see in the top left, coming off the corbels, the lighter color indicating the solar heat gain and possible and probable moisture. You can see some heat gain trapped in the corner, which is to be expected, but some of those fingers coming off the corner are not to be expected and are possible or probable concealed moisture. On the right, you can see almost blocked by the cursor, and I apologize for the cursor in the center on these thermal images. We know better. You can see considerable thermal pattern of suspected moisture and or board gaps, a combination more than likely. Moving to the image on the left, you can see the warmer patterns indicative of possible and probable concealed moisture. You can see something of fasteners and fastener placement. The same as on the right. You can see along accents, control joints, and below the control joint to the left in the thermal image, you can see the much more defined pattern of probable trapped water rundown, indicative there. Let's look below the cursor. You can see some thermal pattern coming off where the guardrail balustrade ends, connects to the wall. If that's improperly flashed, you're going to have moisture intrusion. And I believe that's what the thermal imaging is indicating here. We're big proponents of validating the thermal imaging results with non-destructive Tramex RWS moisture meters where possible, or other types of electronic impedance meters. Worst case, using the pin type moisture meter readings to validate the thermal possible and probable concealed moisture detection. Even on today's glass structures, thermal imaging is very valuable to the commissioning providers for detecting air loss. You can see at the top of the one on the left, very amorphous thermal signature indicating probable air loss. You can see somewhat the same thing in the left thermograph in the bottom there with the amorphous patterns. Somewhat a little more difficult in moving to the right thermograph in the inside corner. You can see signatures of possible and probable air exfiltration, warm air exfiltration during cooler heating temperatures. But you also have to remember that those inside corners trap heat, and you've got to be able to move around, change vantage points to validate that those patterns are probably air exfiltration, air leakage. This was an interesting project where we were scanning the glazing, and the extra warm areas in both of these thermographs indicates the loss of thermal resistance in the glazing system. In this case, failed gaskets and failed joint sealants. EFIS can be scanned, exterior insulated finish systems. You can detect fastener placement. You can see the one on the right. with a pretty widespread fastener placement for the EPS board in the EFS system. Both of these indicate possible and probable concealed moisture beneath the window seals. The one on the left, if you look to the right and above the cursor, you'll see that thermal signature there below the jammed window seal. Sometimes the infrared scan doesn't really provide much information, and that's another reason you need to be moving around and scanning from different vantage points, because you can see barely on the thermograph to the left, the lower right-hand window below the sill. Again, the suggestion of a thermal pattern there, indicating possible moisture intrusion, moisture rundown. Same thing with the infrared image on the right, the bottom window, with a thermal pattern indicating probable concealed moisture. Note the thermal image just to the left of the cursor on that right-hand thermograph, where we've got a thermal pattern indicating possible trapped moisture or extra wide board joint, maybe a damaged pair of boards there with a larger gap. Air leakage is a fascinating subject. During the cooling months, where you've got air-conditioned interior, pressurized interior, you can see just above the cursor the really dark blue indicating the exfiltration of the air that was detected, and required quite a bit of study and moving because it was very slight, but was possible to detect this thermal pattern. These next few slides come to us from Scott Wood, SWA Consulting out of Gig Harbor, Washington State, and we appreciate that. He has some excellent pressurization thermographs to share with us. You can see at the top we have a neutral pressure baseline image, and then pressurizing the building, we have very definitive thermal patterns indicating air leakage. Unfortunately, those of you that are listening that have done much in the way of thermal imaging, this is generally what you find. This is the rule of thumb rather than the exception. It's another reason for the importance of our commissioning with thermal imaging. Positive pressure, getting that exfiltration to show really doesn't require a high pressure change. This is the neutral, the baseline without the pressurization. Same area to the left, and then along that area to the right. I'm going to backtrack. We're talking about the left-hand area in this thermograph. That's pretty brilliant, isn't it? Significant air leakage. We've got a situation with the negative pressure indicated as well. Those of you that have performed both positive and negative can attest to the fact that I really need to do both at times, and a lot of times because of the inability to, for instance, cool the building down economically, or to heat it economically. It might be superior during a cold spell outdoors or during a warm spell outdoors to introduce negative pressure and draw that very warm or very cool outdoor air inboard. You can see how dramatic that can be and what the infrared camera has detected. Again, negative pressure creating very dramatic air infiltration, thermal imaging. The wall to deck, roof deck, or floor interface, but in this case, roof deck is a Achilles heel, a weakness area, and one that more often than not will indicate thermal images of probable air leakage, pretty pronounced, as in the bottom thermograph here. Ceilings indoors, you can have thermal signature caused by moisture intrusion and insulation deficiencies. And by insulation deficiencies, that can be missing insulation, it can be water damaged insulation, it can be insulation that was improperly installed, for instance, in a cavity wall, the insulation not extending all the way to the top, all the way to the bottom, all the way to the studs in the framing. All of those deficiencies under proper conditions are areas where the improper insulation may be detected. And again, it's immediate and non-invasive when performed with the thermal imaging camera. All of us have seen the transition of the above the window header with some loss of thermal insulation because of the difficulties of installing insulation. Similarly, it's much like the inability to force insulation into stud wall framing in a corner or off of a window jamb. But when you get thermal imaging like the thermograph on the left, it's very probable that you have air infiltration or moisture intrusion, in this case, moisture intrusion. And on the right, we have the image of the moisture intrusion that has been validated with the moisture meters. Otherwise, it's correct just to say we have thermal imaging detected that's indicative of possible or probable moisture intrusion. We're not using moisture meters with our infrared cameras. We're using temperature readings and obtaining thermal patterns, thermal signatures. You can tell through these that I really like the dramatic iron and iron bow palettes for thermal imaging of the possible and probable concealed moisture. The one on the thermograph on the right, you can see the much darker jamb to sill transition there, and moisture in a wall cavity, depending on the type of insulation and the type of stud wall framing, can actually climb or rise, migrate up 2 stories. So it's very beneficial with your infrared camera to try to identify a dark, cold temperature thermal pattern such as this, and get as close to identifying a possible source for the problem with the non-invasive, non-destructive thermal imaging. Otherwise, you got to start tearing into drywall, which can be very disruptive. Along the floors, we've got 4 modes. We've got the liquid trapped moisture itself that can be detected that's cooler if it's coming in during rainfall. You've got air infiltration along the floor lines. You've got the evaporative cooling, and then you've got a combination of those that can contribute. These are all moisture that's been validated, and the one on the right, not visible in the flooring, but certainly visible with the thermal imaging. It's interesting to note that we don't have any thermal pattern coming at the inside corner. And I'm talking about the thermograph on the right. We don't have any thermal pattern at the inside corner, and we don't have any signs of water rundown along the left-hand jamb as well. I mentioned early on that we'd be talking about 3 sources for training. One of those is United Infrared and the many different types of courses that they offer, including block walls, data center infrared moisture find IR for the building science. That would include all aspects of the ceilings and walls and exteriors. We have roof scan IR focused strictly on the roofs, and then energy scan IR focused from an energy assessment standpoint. My friend Jim Sefrin was just quoted this past weekend relating to the CDC and why thermal imaging isn't being used at all the airports to detect the COVID-19 virus. Very knowledgeable individual, one of the oldest providers of infrared training, Infraspection Institute, with the contact information there. And again, I mentioned slides from SWA, Scott Wood and Associates Consulting, Gig Harbor, Washington, with his information there. Scott holds infrared training, building science training throughout the country. Very beneficial, very professional, very well informed. I didn't cover mechanical, but much like what we've covered for roofing, the thermal imaging of ductwork can detect air infiltration and exfiltration, missing thermal resistance, and thermal bridging. Pretty dramatic again in the iron palette with our infrared camera, detecting missing insulation in the metal wrapped duct. Another aspect for commissioning electrical, I'm not qualified to speak on it, but I wanted to show you how dramatic the proper thermal imaging can be. These come to us from John Gutierrez from New Jersey, and you can tell he's working with a very high resolution infrared camera. And I want to thank everybody for listening in today to the Tech Talk. Welcome any questions, and want to wish you a really good week, the balance of the week, and let's all pull together and hope that we can stop, get rid of, and put this COVID-19 virus in the rearview mirror. Thank you very much.
Thank you, Ben. We do have a question that has come in, and just as a reminder, if you do have a question, you could put in your question right now. But we have here, how important is it to collect baseline data of the interior conditions of the building to assist interpretation of the images? Temperature, interior, pressure at ground floor, at top floor, etc.
It's vital, it's critical if you're going to be doing any pressurization at all, and pressurization or increasing or decreasing the temperature to the indoors. You need baseline thermal images documenting conditions prior to making the changes. It's not critical to document those things if you're scanning the exterior because you're looking for anomalies, and that's the key word. You're looking for thermal images, signatures that are atypical, they're not symmetrical, so they're anomalies to be explored further with additional instrumentation.
Thank you, Ben. It looks like that's all the questions we have now. I just have a quick reminder, and then if there is a question that pops in while I give you the reminder, I will let you know. If you haven't already done so, don't forget to renew your membership so you can continue to receive these Tech Talks and valuable benefits. There is a new Tech Talk password that will be emailed out after this Tech Talk is posted onto the website. I'll send out an email to all those who have renewed that new password. And then also don't forget, we do have a spring webinar series that's posted to the site, and registration is open for that. Ben, it doesn't look like, oh, wait, we have one more question, Ben. Let me get it here for you. Do you have recommendations for techniques at various interim stages of construction where portions of the assembly can be checked? Or is the reality that these things must await completion of the enclosure?
We highly recommend as commissioning providers that the infrared thermography be used after a major moisture intrusion, and that's a major moisture intrusion into a roofing assembly or a partially completed wall assembly, to quickly identify the moisture intrusion and address it with permanent repairs rather than temporary or topical repairs, if you will. This might involve opening up some walls, removing drywall, removing damaged insulation, but we feel, working as owner advocates, that that's appropriate and necessary to avoid dark biological growth, if for no other reason.
Great, thank you. Well, I think that is all the questions we have. Ben, we really appreciate your time and expertise today. And on behalf of the BCA, I would like to thank everyone for your participation today, and have a great day. Thank you all.
Thank you.